back. Example 8. Now, find the volume of the solid obtained by rotating the region between these two curves about the line y equals -1. So notice we finished rotating about y, about x. We even finished rotating about some other line. Now here is a horizontal line, y equals -1. We already know the intersection points of these two curves from our previous examples, right? 0, 0 and 1, 1. Now you want to take this region and rotate it about a line y equals -1. Y equals -1 is a horizontal line well below the x-axis, okay? When we rotate it, what happens? There you go. That's a huge sweep. So it's like a huge, another big donut with a big gap, hole in the middle, right? So that's the solid part, outer part, and inside is a big hole. So because we rotated about y equals -1, all our cross sections are vertical. You see, because we rotated about a horizontal line, our cross sections are vertical. Each cross section is again region between an outer circle and an inner circle. So outer circle goes around this lower curve. That lower curve corresponds to the upper curve, that is square root x. Inner circle corresponds to the lower curve here, that is y equals x cubed. That is the inner curve. Okay, so there is an inner curve and an outer curve. Okay, let's understand. This solid is supported. So look at that. We have we have vertical cross sections. So those cross sections go from 0, 0 until 1, 1. All right. So you're going from over the x-axis from closed interval 0 to 1. The width of each slice cylinder, those are called washers, by the way, right? Sliced cylinders. Width is delta x. Each cross section for each x is a region between two concentric circles. Now let's understand the outer circle. Outer circle has radius 1 plus square root x. Well, that's the center of your circle. To find the radius all the way there, first you have to go to x-axis. From the center to x-axis, that distance is 1 because this is line y equals -1. So you have distance 1 plus the distance, vertical distance, that is y coordinate. But y coordinate for this curve is square root x. That's the definition of that curve. So the entire radius of the outer circle is 1 plus square root x. Whereas for the inner circle is 1 plus x to the third. So outer circle has radius 1 plus square root x, inner circle has radius 1 plus x to the third. So the area of each cross section is outer circle area minus inner circle area. Pi radius squared minus pi inner radius squared. So the volume of the solid is integral 0 to 1 area of the outer minus area of the inner dx. Pi is a common factor. You can bring it out. It's constant. 1 plus square root x power 2 is 1 plus 2 square root x plus x minus 1 plus x cubed power 2 is 1 plus 2x to the power third plus x to the power 6. Simplifying, the ones cancel. All you are left with 2 square root x plus x minus 2x cubed minus x to the power 6. When you take its integration, don't forget to carry the pi. This integration, x to the power 3 halves over 3 halves with a 2 there, so 4/3. This is x to the power 2 over 2. This is x to the power 4 over 4 with a 2 over there. X to the 7 over 7 with a negative. Okay, keep track of signs. Limits of integrations 1, 0. 0 fetches me nothing. I just need to substitute 1. 1 to any power is 1. So I'm left with 4/3 plus half minus 1/7 times pi. Assuming all my calculations are correct, I get pi times 25 over 21 cube units. All right. So this was rotating a region about a line which is neither the x-axis nor the y-axis, but it is parallel to the x-axis. Okay. Next problem, next example, we will go over in our next video.